Thank you very much for your nice introduction. Now I am going to talk about ionic liquids. Ionic liquids are bicompatible co-solvents for the structure and stability of biomolecules. Before this, first of all, I would like to express my sincere thanks to the Indian Science Congress Association for giving me an award also. Yesterday, I received Professor K.K. Katiyar Endowment Lecture Award in New Biology that includes biochemistry and biophysics. Now, I am going to talk about ionic liquids or biocompatible co-solvents for the structure and stability of biomolecules. My main research are focusing in my laboratory that are protein folding, unfolding in the presence of osmolytes, protein folding, unfolding in the presence of ionic liquid, thermodynamic properties of liquid mixtures, critical liquid mixtures, polymer phase transition. So, as we know, every organism, including us, everybody is facing different kinds of stresses that include environmental stress, heat effect, pH changes, radiation, cold, and the concentration effect. So, if every system is facing these kinds of stresses, then what is happening? The organism is going to denature because of this stress. If we have more stress on our body, we will denature something. So, like that, this organism is denaturing. So, how to control this stress? For that, you may see here, if you see the proteins, usually we have many kinds of stresses, among them chemicals, pressure and heat. If you have these kind of stresses, the protein is going to denature because of these stresses. So, how to control this stress? For that, nature has given some kind of co-solvent. So, if you add these co-solvents, these co-solvents are giving protection against these three stresses and keeping into the normal folding form. Now, we have to see which co-solvent is suitable for this preventing of these stresses. So, if you see the chemical point of view, mainly we have two kinds of co-solvents. That in first, organic solvents. If you consider organic solvents, as we know, these organic solvents are creating air pollution, ozone depletion and human health related problems. So, that indicates these organic solvents are not suitable for preventing the stresses. So, then if you see the ionic salt, you may consider, for example, sodium chloride crystals, the melting point is 800 degrees Celsius nearly. So, this is not possible to control in our laboratory level. So, that means you may see other ionic salts also having more melting points. So, this also not suitable to prevent this kind of stresses. Then we can't play with the chemistry. At the same time, the chemistry is our life, our future. So, without chemistry, we can't do anything. So, what is solution? For that, nature has given us ionic solvents. These ionic solvents, ionic liquids, these are part of the green chemistry. So, these ionic liquids are offering unique and novel properties. So, I am not going to detail about these ionic liquids due to lack of time. So, ionic liquid means, what is ionic liquid? Ionic liquid is a combination of ions, cation and anion. Then the question arises immediately, sodium chloride is the combination of ions, cation and anion. So, why you are calling this ionic liquid? These ionic liquids are liquids at the room temperature. Most of the ionic liquids are liquids at the room temperature. Some of the below 100 degree Celsius, they are liquids. So, this no need. So, if you see the ionic liquid publications throughout the world, day by day they are increasing. So, the first place is occupied by the China. The publication related to the ionic liquids, the first place is occupied by China. So, we are in very, very low position. Then not only this ionic liquid field, you may see other physical chemistry, because I am basically physical chemistry. So, I am highlighting physical chemistry related journals. In all this, you may see here, China is first place, Journal of Physical Chemistry A, B, C and Journal of Physical Chemistry letters also. In all places, China is occupying first place, then we are least, not 50% of this, very less. So, why? We are competing population wise, competing with equal to China. When we are producing the papers on research, not only this research, everything China is dominating all countries. So, that we have to think Indian generation, because we are competing in all aspects with China except research point of view. So, this we have to think. So coming to the ionic liquid applications, we have lot of applications. So, recently we have reviewed the applications related to chemical point of view in this physical chemistry, chemical physics perspective. So here we have highlighted the most applications of the ionic liquid in different fields of the scientific fields. So, if you see the generation of the ionic liquid, The history started 1990s like a small tree applications. Later on, it expanded very big tree in different scientific fields from biotechnology, medicinal applications, analytical, thermodynamics, electrochemistry, organic chemistry. People nowadays are also working in nanotechnology. So, here we have reviewed many applications, different scientific fields in different journals. Recently, not recently, in 2012, we have reviewed the applications of the ionic liquid in chemical review, which impact factor is 45.2. This is the highest impact factor in chemical sciences. So, we reviewed the applications of the ionic liquids related to protein folding studies. Later on, we have reviewed some different journals, the different applications. So, we know the proteins are very sensitive and highly complex system in their folded state. This is general statement. So, in the presence of co-solvents, the proteins can be stabilized or destabilized. So, destabilization or destabilization is depending on the co-solvents. Fine. So, before seeing this, what is protein stability? So, the protein stability is defined as the difference in the free energy between native state and unfolded state. So, you may see here, this is the protein native state. At this state, the protein is more stable. If you change one of this one, the protein is unfolded. Here, protein is unstable. So, the difference of the free energies of these two states gives protein stability. So, when protein is in folding state, the free energies are increasing, whereas protein is in unfolded state, the free energies are decreasing with increasing concentration. So, using this basic concept, one can predict whether protein is in folded state or unfolded state. So, if you see the interaction of the protein folding studies, we have mainly two types of interaction, hard interaction and soft interaction. So, the classification of protein stabilities, we have mainly thermal stability, chemical stability and kinetic stability. So, if you see the literature, the protein folding studies in the presence of various solvents is hugely published, whereas protein folding in the presence of ionic liquid, the first report came by Robert Flowers in Protein Science in 2000. This is the first report, the protein folding studies in the presence of ionic liquid. Later on, the Ipora from Spain, what he did, he has taken 4 different solvents, water, sorbitol, propanol and ionic liquid. You may see here, in the presence of the water, the protein starts denature 53 degrees Celsius. That means the water is giving protection up to 53 degrees Celsius. Whereas in the presence of sorbitol 69, in propanol, this is already I told you, organic solvent is not protecting, so this is denaturant. In the presence of ionic liquid, the protection is 64.01 degrees Celsius. So, if you compare these 4 solvents, this ionic liquid is strong stabilizer, because here they used 0.5 molar of ionic liquid concentration, whereas in sorbitol case, they have taken 3 molar sorbitol concentration. So, this concludes that this ionic liquid is a strong stabilizer for the alpha chymotrypsin. So, in my laboratory, what we are doing? We are using simple amino acids, cyclic dipeptides, insulin, myoglobin, hemoglobin, consanguine A, bromelain, alpha chymotrypsin. So, in these proteins we are working in my laboratory. So, first what we did, we have taken simple amino acids, glycine, diglycine, triglycine, tetraglycine in the presence of different kinds of ionic liquids. This slide shows clearly the free energy changes are increasing with increasing the ionic liquid concentration. In all 4 cases, we observe similar trends. In introduction, I mentioned you, when free energies are increasing, that means the protein is in folded state. So, this concludes these simple amino acids are in folded form in the presence of this ionic liquid. Then what we did, we have taken cyclic dipeptides. Then we have used different kinds of ionic liquids. So, here also we observe same conclusion. You may see here the free energy changes are increasing with increasing the ionic liquid concentration. We observed in 4 cyclic dipeptides similar trend. So, that means these ionic liquids are giving protection, simple amino acids and cyclic dipeptides. Then what we did, we have taken alpha chymotrypsin, which this enzyme is folded into 2 domains. So, this enzyme is compressed with 245 amino acids. Because why we have chosen first, this enzyme is having a lot of medicinal applications. So, that is why we have to see how this protein is responding against the ionic liquid. So, first what we did, we have taken 5 different kinds of ionic liquids. So, we have used transition temperature by CD analysis. So, first you may see clearly here, the protein in the presence of buffer means we are using control point. So, in the presence of buffer, the protein starts denature 42 degrees Celsius. Whereas in the presence of ionic liquid, you may see here the transition temperature is rapidly increased up to 65 degrees Celsius, which is obviously higher than this buffer point. So that indicates this ionic liquid is keeping protection up to 65 degrees Celsius. The other ionic liquids also behaving similar trend. So then what we did, we have calculated the delta free energy changes unfolded state. So here also we observed all free energy changes are higher than this buffer point. So this concludes these ionic liquids are behaving biocompatible solvents or stabilizers, not only for simple amino acid cyclic dipeptides but also the globular protein. Then what we did, we have taken another conclusion A. So here also we used different kinds of ionic liquids. Here also you may see all ionic liquids transition temperatures are higher, whereas in the case of acetate combination of ionic liquids, they are weak stabilizer, whereas in the presence of phosphate combination of ionic liquids, they are showing strong stabilization to giving protection against the temperature for the protein structure. So then what we did, we have taken different concentration of the ionic liquids. So what we observed here, at low concentration, you may see this wavelength emission spectra shows the protein 320 nanometers shows the tryptophan or tyrosine of the protein structure is stabilization. So here you may see in the at low concentration, the protein tryptophan region is not changed. That means at the lower concentration, the protein structure is stabilized. Whereas in the presence of higher concentration, this wavelength is shifted towards the red shift. That means this emission spectra is shifted towards this higher wavelength. That indicates the protein is completely denatured. So at higher concentration, protein is denatured. So what we can conclude here, at low concentration, these ionic liquids are giving protection and keeping into the folding form, whereas at the higher concentration you may see these ions are occupied the protein surface and disturb the functional activity at higher concentration. Fine. So we have seen so far these ionic liquids are strong stabilizers. So what is mechanism is behind this strong stabilization? So if you see the mechanism point of view, when we add the aqueous ionic liquid, first water molecules are forming hydration layer throughout the surface of protein structure. So this is hydration layer. Then what these ionic liquid are doing, they are trying to attack this protein surface to disturbing these functional activity and functional groups. Due to steric repulsion, these ionic liquids are excluded from the water molecules at the protein surface. You may see here, these all ionic liquids are excluded from the water molecules at the protein surface. So what we can explain, if you put the aqueous ionic liquid, first water molecules are occupying in the protein surface, forming the hydration layer. At the same time, these water molecules are interacting with ionic liquids, here also forming one hydration layer. If you have two hydration layers, they never interact. There we can observe unfavorable interactions. You may see this cartoon. This is the protein. This is the aqueous layer, hydration layer. Then this is ionic liquid. So here we have one hydration layer. So this is also water molecules hydration layer with ionic liquid. Here also you have hydration layer to the surface of the protein. So these two hydration layers never interact. They are trying, but due to steric repulsion, they excluded from the surface of the protein. So this is the main mechanism is involving in the protein stabilization studies. So here you can see here clearly unfavorable interactions are observed due to the steric repulsion. So we observe unfavorable interaction between protein functional groups and ions of the ionic liquid. Then if you see the classical denaturants, we have mainly urea and guanidine combination of salts. You may see in the presence of urea, first the urea is denaturing the hydration layer of the protein surface. Then what this is doing, this is slowly attacking on the protein surface and occupying to the protein surface and disturbing the functional activity of the protein groups. So when protein is enfolded, that means protein is stabilized, we can observe preferential exclusion and also unfavorable interactions. You may see here, this all ionic liquids are giving protection to the protein structure. Whereas in the case of denaturant case, here we can observe preferential binding between the ions of the ionic liquid and protein functional group. See here, ionic liquids are excluded, but here ionic liquids are disturbed. So only my 50% talk over, remaining 50% is. So I will skip these slides. They are very interesting, but due to lack of time, I am not explaining. I will explain here one thing. whether these ionic liquids are behaving refolding additives or not. So for that what we did, I am not showing these things, very interesting slide, but due to lack of time I am not showing. So what is refolding? So this is native structure of the protein. So what we did, thermally denatured, if increase the temperature, the proteins are thermally denatured, then we are adding ionic liquid. So what my ionic liquid is doing, whatever you lost here, that is recovering and forming renaturation. This we are calling refolding. So you may see here clearly, this is the different ionic liquids. So here you may see this is the native state of the protein structures of epilicities, whereas refolding state you may see that both epilicities native state and refolding state almost same. So then we did NMR studies also. In the presence of buffer we have these kinds of peaks, and in the presence of ionic liquid this is native state, we have like this is a refolded state. We have seen almost same peaks. So that indicates these ionic liquids are behaving refolding additives against the thermally denatured protein. So then what we did, chemically denatured studies. So what we did, we have taken protein and unfolded in the presence of urea, then again refolded. You may see this is unfolded and this is native state and this is refolded state. So these two states are almost matching. So these results are highlighted in Organic Biomolecular Chemistry, which is publishing by the Royal Society of Chemistry. These are highlighted in this journal. This I am skipping. So what is happening here? This is protein folded state. In the presence of urea, protein is completely unfolded. When we add the ionic liquid, again it is refolded. These are recently we published in PCCP journal. I am skipping. So if it here, this is last slide. So what we observed here, so this is thermally unfolded state. So if you keep the protein in low temperature, that is cold induced unfolded state. So here whether they are stabilizing or not, for that also we have proved here these ionic liquids are giving stabilization at very low temperature also. So this is also low temperature they are protecting. Then these are the different and also here one more recent results are also highlighted in PCCP cover page. So in first slide I showed different kinds of stresses. Now based on my results we can conclude whatever we have seen in the introduction, different kinds of stresses, these all stresses are controlled by my ionic liquids. These all are published in different journals. So this shows these ionic liquids are biocompatible solvents for the biomolecules. So finally I want to acknowledge the financial support from Department of Biotechnology, New Delhi, Department of Science and Technology, Council Scientific of Industrial Research, New Delhi, University of Grants Commission, New Delhi, and I already told you for the ISCA, which is given award for me, Professor S.S. Katiyar Endowment Textile Award. Yesterday I received in the new biology section. So these are my research students. So these all are working in different countries as a postdoctoral fellow. I want to highlight him. He is working in MIT. This is the prestigious university throughout the world. He is working as a postdoctoral fellow in MIT. So these two are waiting for Viva. These all are working in different fields. Finally, I want to thank for your kind attention. And this shows person is working on ionic liquid. This ionic liquid always keeping B positive. There is no negative thought. Thank you very much.